Namah Shivaya. I am Hridya Krishna R of S3CSEC from Amrita Vishwavidyapeetham, Amritapuri. I am here to present a video on data structures to reverse a queue using recursion. So in this video, I will be showing you how to reverse a queue using recursion with an example. So beforehand, we need to know a few functions that are required in queue. First one is enqueue, which is used to add an item to the rear of the queue. Dqueue removes an item from the front of the queue. The isEmpty function helps to check if a queue is empty or not. So in this example, I have given a queue as input, which is 6, 5, 4, 3, 2 and 1. And the output I am obtaining is 1, 2, 3, 4, 5 and 6, which is the reverse of the input. So I will show you how to do this in this video. So there are a few steps in this recursive algorithm. So let's check what those are. The first step is to check if the queue is empty. So by using the isEmpty function, we will check if it is empty. And if it is empty, we're going to print empty queue and there is nothing to be reversed. And if the queue is not empty, we will pop out the elements from it. So the first element will be popped if the queue is not empty. Hence, the same procedure will be continued until the queue is empty. And the step 3 says that then call the function reverse queue for the remaining queue. So once the first element of the queue is popped out, the same function reverse queue is called for the remaining queue. Now push the popped elements into the reversed queue. So after all the elements are popped out until the queue is empty, the elements that are popped out will be pushed into a new queue, which will be the reverse of the initial queue. So let's see how it is done with the illustration. So the example I have taken here is 5, 4, 3, 2 and 1. So first what we are doing is we are checking if the queue is empty. Here the queue is not empty. Hence what we do is we pop out the first element, that is 5, from the queue, and we take the remaining queue as the main queue. So the main queue now after popping out 5 is 4, 3, 2 and 1. We do the same procedure over here by checking if the queue is empty. As the queue is not empty, we'll pop out the next element, that is 4, and then give the remaining queue. The same is continued, and so 3 will be popped out and later 2 will be popped out until 1 is there as the only element in the queue. As the queue is not still empty, we will pop out the first element, that is 1. After popping out 1, what we obtain is an empty queue. So now we have obtained an empty queue, and hence we are going to stop the procedure over here and return that the queue is empty. So up to now what we have obtained is so many popped out elements. So we go back one by one from the last. That is, when we reach up to 1, we will push the last popped element, that is 1, into the new queue. As you have seen here, I have pushed 1 into the new queue. Then comes 2. 2 will be pushed to the new queue when 1 is already pushed. And after 1 is being pushed, it returns from this function and goes to the previously popped element. Similarly, when 2 is pushed, it goes to the previously popped element, that is 3, after returning from that function. Similarly, it returns from the function 3 and then goes to the previously popped element 4. Similarly, it goes to 5. So each time it goes to the previously popped element, it is being pushed into the new queue. So here it starts from 1, then comes 1 and 2, then 1, 2, 3, then 1, 2, 3, 4, and then finally 1, 2, 3, 4 and 5, which is the reverse of the initial queue, that is 5, 4, 3, 2 and 1. So this is the procedure in which we are doing this. Let's see how it is done with the code. This is the code that I have written for the procedure. So first we are importing the packages, and then we are taking the first class, that is the main class, public class queue reverse. In this first function I have declared is void is empty, in which it checks if the queue is empty or not. So if the front and rear are both -1, that means the queue is empty, and otherwise it returns false. And hence then I have also given the enqueue and dequeue functions in which the queue is being added with an element or deleted with an element. I've given the cases only which are required in this problem. So the main function, that is void reverse queue, is also described here, in which if the queue is empty, it returns the whole queue. Otherwise, if it is not empty, what happens? It is storing the element that is being popped out. That is the first element. It is being stored, and then it is being dequeued. So once it is being stored, that is by int data equal to q dot front, the first element, and then q dot dequeue, in which the first element will be dequeued or deleted, and then q is equal to reverse queue of q. Here we have taken the concept of recursion, in which after checking the first element, it continues the same function for the remaining queue, and then after that, after all the elements are being dequeued, what happens is we get an empty queue. At that time, we are going to enqueue the whole popped out elements into the new queue, that is q dot enqueue of data, where data will be the popped out elements of each stage. And after that, what we are doing is completing the function by return q. So we'll be completing this and then returning q. So by this function, by this code, we'll be getting the final answer, that is the reverse of the input that we are providing. So this is how we are reversing a queue using recursion. Thank you for watching my video and have a good day.